Hi, Science 133. This is Robin Colbert. I'm going to be talking to you today about, let me think, we're in week 3, um, experiment 2, or lab experiment 2. So the focus for the experiment for today, or for this week, was about momentum. Excuse me, and I'm going to be looking at my notes a lot throughout this. But anyway, momentum is talking about the product of the mass of an object and its velocity. So when you're talking about the mass, which is different from the weight of the object, you're just talking about how much space it takes up in an environment. And then the velocity is talking about the speed of an object and then the direction that it's going in. So that would be kind of like if a car is going 50 miles an hour and it's headed east. Both of those things would contribute to the velocity of the car. So it's not just the speed, but it's also the direction because it's heading east. So that was what the focus of this week's experiment was talking about momentum. And force and momentum are related because of Newton's second law. So when I had to do the simulation, it was to help calculate what the momentum was. And in the simulation, excuse me, it was 2 carts. It was a red cart and a blue cart. And you had to adjust I'm sorry, I have to look again. You had to adjust the mass of both carts, and then you had to adjust the initial velocity of the carts. So what their speed and direction before they ran into each other. That's what you had to adjust on there. So there were 3 trials. In each trial, you had to change both the velocity and the mass for both carts, the red cart and the blue cart. So during the first trial, the mass of the red cart was 0.5 kilograms, and its initial velocity was 0.1 meters per second. And then the blue cart, the mass was 1 kilogram, and its initial velocity was 0 meters per second. So after that simulation was created, what I noticed was that after they collided with each other, both carts pushed away in opposite directions of each other. However, the blue cart moved away faster from the red cart. And then in the second simulation, the mass of the red cart was 1 kilogram, so it went up 0.5 kilograms, so it was increased. And the initial velocity stayed the same, so it was still 0.1 meters per second. And then the mass of the blue cart, that stayed the same, and it was 1 kilogram. And then its initial velocity was still at 0. So basically the mass of the red cart increased, but all the other factors stayed the same. So this time when they collided, both of them pushed away in, only one of them pushed away, and that was the blue wagon. The blue wagon moved in the opposite direction. So these were the 2 cars. They bumped into each other. This one moved, and then the red one stayed. And then the third time, for the third and last simulation, the red cart's mass stayed the same again. So it was still 1 kilogram. Its initial velocity was also the same. It was still 0.1 meters per second. And then the mass of the blue cart was also the same. So it still remained at 1 kilogram, but its velocity changed for the blue cart. It became negative 0.1 meters per second. So after this simulation, both of them actually pulled away in different directions or opposite directions, and they actually both moved at the same speed. So when they both ran into each other, they both bounced back and then just kind of moved out like that. But they basically moved at the same rate. And after I documented the each cart's momentum before and after the collision, and then the total momentum that both of them had together, what I noticed was that the total momentum at the end for both carts was equal. So both of them. So I'll turn back over. So for the first simulation, the first time I did it, both of them had a total momentum of 0.0500 kilograms times meters per second. So, which I think is 1 Newton. Or no, it should be meters per second squared. But yeah, both of them had the same momentum after they were added up together. And then the same thing happened during the second simulation. After I totaled up their momentum before and after the collision, both of them had 0.100 kilogram meters per second, and that was before and after. And then the same thing with the third simulation. They both ended before and after at 0 kilogram meters per second. So what the conclusion that I drew basically from all three simulations was that the momentum before a collision is going to be equal to the momentum after a collision to balance out, which applies to, I gotta think which one it is, Newton's third law, which states that for every action there is an equal and opposite reaction. So the momentum having the same, or the carts having the same momentum before and after the collision basically solidifies Newton's third law about every action having an equal but opposite reaction, because they moved in different directions, but the momentum was still equal on both sides, which is very interesting. I think that was all that I wanted to share. I'm just gonna look through my notes really quick for a second. Yes. So that was the main thing that I wanted to share, was about Newton's third law. So I think that's it for this week. So thanks again for listening, and have a good day. Bye.